And we should be live. Welcome everybody to another live stream repair. We've got 3 HomePods that were sent in today for repairs. All 3 of them happen to seem to have the same issue reported. That is no bass. Some people will describe this as like a tinny sound, or like it sounds like it's over a PA speaker. But the real root issue here is that there is no bass coming from the Apple HomePod here. So we're going to start off with Korey's HomePod here and go ahead and get started. So we're going to go first and check our symptoms. We don't want to dive into repairs looking for the wrong thing here. So we've got our power, and we're going to go ahead and plug that in. And good. Okay, so it's powering on. We'll wait for that to boot up. Come here, Bailey. Come here, pupper. Yeah, lick, lick, lick. Alright, HomePod has finished booting up. Let's get Siri complaining here so we can take a quick listen.
I'm having trouble connecting to the internet.
Yep. That's certainly a lack of bass there. So let's unplug the power and jump right into repairs here. Let me clean my spudger off so we don't get any extra schmoo all over their mesh here. And here we go. We're just going to wedge that in there, and then we're going to work that all the way around. If you're doing this yourself, it might not be obvious on stream here, but you go around this a few times. You don't just do one lap and then try to pry it off. That's how you break it. Do a few laps around. Make sure you really cut that adhesive up. And then once you've gone around it enough, the top should pretty much just pop off for you. Just like that. Then we'll get our T6. And we'll start taking out some screws. We can get our pry tool back. Slide that under our display. And then we're going to use a plastic tool to wedge under that and actually pry up with our plastic tool here so we don't mar up any of this plastic or scratch any of this PCB as we pry it up. Balls. There we go. Disconnect that display. And then I like to stick this adhesive back into place before I move forward. So we'll do that here real quick. That'll do. Now we can unscrew this frame. go ahead and take your guesses now. Do we have a blown subwoofer from too much DC offset? Or do we have a short somewhere on the amplifier with a totally good bass speaker? Personally, I always hope that the bass speakers are always still good, because then I don't have to replace the bass speaker and repairs end up being cheaper for you guys. So, get that logic board out of the way. And one quick test we can do right here, just going this far, to quickly gauge if the bass speaker is still good or not, is we're going to very gently push straight down on the woofer just a little bit and try to feel if that's got nice smooth actuation or if it's kind of gritty. And I think that sounds kind of goobered. But let's carry on and see if that subwoofer is indeed roasted or not. Gonna get these rubber screw covers removed so we can unscrew this basket here. Oh boy, I can already smell. I can smell it already. The subwoofer's definitely cooked. Dang it. Well, that's okay. I still have a couple of subwoofers sitting around to do these sort of things. But I am going to have to start hunting down a few more HomePods just for parts, so I've got a couple more good subwoofers on hand. Smelly, smelly. If the bass speaker's already fried, then I'm going to guess that we've got at least a couple 100 millivolts of DC offset here, if not 2 to 3 volts at most. Obviously, once it reaches past like 3 volts, it'll start triggering those death farts. But it only takes a couple 100 millivolts of DC voltage in your speaker to cause damage to it. Not that much. At least it would seem. I like to try to stack these up like this, so that when it's time to put them all back together, I can just grab them all in one go. Okay, and then we're gonna detach this ribbon cable here from the top basket before we go and pry this off, because we don't want to damage or tear this cable as we pry this basket off, because obviously this is adhered right here on the underneath. So we're just gonna pull that down with some fingers, use another finger to sort of wedge that off. And there we go. We got our main logic cable detached, so now we can get into the good stuff. Let's pry. Seems to be coming up nice. Very nice. And then we're going to go around again. That feels pretty loose, so we should be able to pry that off by hand now. There we go. Now we can unscrew our subwoofer. You can lift that out, being careful around that ribbon cable there until it's free. Unplug that woofer from the amplifier down there. And we can get our first up-close look at this subwoofer here. Oh yeah, that smells bad. And yikes. That voice coil is cooked. It looks just like this. Nice and roasted. So unfortunately, we will need to replace this bass speaker for them. But that's okay, I've got a few. Let's push that ribbon cable through this plastic ring here so we can unscrew this ring and take it out. We don't want to just replace the subwoofer and call it good. We need to repair and correct the actual cause for why that bass speaker had a meltdown. So we're going to tear this down a little further. There we go. Let's get that power supply unplugged. Then we can unscrew it and take it out. Get our hooker. We're going to hook underneath where that connector for the power supply is so we can pull that straight up and out. Power supply looks good. Let's get the ribbon cable detached from the amplifier down there. And then we can take our amplifier out. And there we go. Let's resituate ourselves here. Okay, just do a quick visual inspection of this amplifier before we dive into repairs. Make sure there's nothing obviously damaged. That resistor right there loves to blow up, but that looks good. Everything else looks all right. So before we do any actual repairs, we're going to put this amplifier back together a little bit here so we can power it on. And we're going to plug in our test woofer here. That's got a connection to our multimeter so we can measure how much DC voltage this amplifier is generating and spitting out onto the subwoofer, because that is most likely the reason why that subwoofer blew up. Alright, let's power it up. Looks like my multimeter is going to need a new battery soon. Hope we can make it through today's repairs before I need a new one. Alright, HomePod has been booted up again. Let's get that amplifier actually powered on here by triggering it, and we'll get our DC measurement here. Oh boy. So we're past 200 millivolts for sure, and I saw the subwoofer bounce up. Okay, goodness gracious. Whoa, 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 whoa. We're fluctuating around between 1 and 2 volts. So that is certainly enough to cause damage to your subwoofer speaker. And I bet you if we play with the subwoofer connector here, we'll see the subwoofer itself bounce around, and we'll hear a pretty healthy pop. Yes, indeed. Oh boy. Okay, let's get all of our tools turned on here and warmed up. Take our test parts off this amplifier and do some fixing. The reason why we see so much voltage on that, so much DC voltage to be specific, on that subwoofer, is most likely on the back side here. You've got 4 filtering capacitors, and one or a few of them tend to lose their effectiveness at filtering DC voltage from the audio amplification before it is of course amplified and then sent to the subwoofer. So the DAC converts the digital audio signal to analog. That gets passed through the filtering capacitors before that weak analog signal is amplified. And if there is any DC voltage present before that audio signal is amplified, then of course the amplifier is just going to, of course, amplify anything that it's given, be it AC audio signal, DC voltage, or otherwise. And it's going to start frying your stuff here. So what we will do is replace those 4 filtering capacitors that are responsible for allowing that DC voltage through. And then, for good measure, we are going to replace the Schottky barrier diode on the other side of the amplifier. It's usually responsible for no power issues, so it won't have anything to do with our no bass issue here, but we like to replace that diode that causes no power issues, whether no matter what it is you send your HomePod in for, to hopefully prevent that other oh so common no power issue from creeping up shortly after fixing one thing. So here are our 4 faulty capacitors. It could just be one of them, it could be 2 or more of them, but we just go ahead and replace all 4 of them since there's no, at least to my knowledge, there's no really great way to test these. These tend to quote-unquote test fine with most of my conventional methods, but lo and behold, you replace them and then your DC offset goes away. So let's go ahead and do just that. We're going to get our hot air out, and we're just going to blast those caps with 500 degrees Celsius of heat at pretty much max airspeed here. We're at about like 80% airspeed. Get those capacitors pulled off and replaced with new ones. And then, like I said earlier, we will replace our Schottky barrier diode for good measure, prevent that no power issue from creeping up on them, and then we'll retest it, see if we got rid of that DC voltage on our subwoofer. Once we've done that, then we can put this back together, put in another good working subwoofer, and they'll be all good to go. just like that. Let's get our replacement capacitors out. If you want to know which parts that I use, including like the values of the parts, like voltage and tolerance and size, part numbers to be specific, I've got all that information up on my website at nixfix.com. Head over there, go to common issues, find your issue, and then I've got steps on how to diagnose the issue, how to repair it, and then the parts, the exact parts that I use. So these are 16 volt, 10 microfarad size, 1206 MLCC ceramic capacitors that we've got here to replace them with. Same spec that Apple used when they originally manufactured these, but from a reputable manufacturer. Gonna put some flux on there and then get our soldering iron, and we are going to tin those pads with some nice low temperature solder so that when we put our new capacitors on, we don't have to use so much heat to put those new capacitors on. And that should hopefully give those capacitors a good long lifespan. There we go. Alright, just a little more flux. You can never use too much of this stuff. Grab our hot air again, and we will put our new capacitors on. There we go. And then for good measure, we're going to slap that with a little more flux and one more round of heat just to make sure those have a nice, good, solid contact with our board here. Make sure we don't have any bridges, unless their name is Jeff. There we go. Looking pretty snazzy. Nice and solid. Very good. Okay, so that should fix our DC offset. And then before we put this back together, like I said, we want to do a little bit of preventative maintenance here, and we're going to replace this diode right here. Again, this has nothing to do with our DC offset, our no base issue. This is purely more for preventative maintenance. We do this with every single repair regardless of what they come in for. We just see this diode short and cause our no power issues so often that we just go ahead and replace this every single time. Every single time. So pretty much the same process as our capacitors there. We're going to heat it up, pull it off, and then put a new one on. This also gives our capacitors back there just a little bit more time to cool off. One thing to keep in mind when you replace those capacitors, of course, if they are hot, or rather I should say, those capacitors by nature simply just lose their effectiveness at filtering that unwanted DC the hotter they get. So we want to make sure that those are as close to room temperature as possible when we go back to do our final testing here to make sure we've gotten rid of that issue once and for a long time all. Nothing lasts forever, but we can try to make it last as long as possible. And a $300 smart speaker should certainly last more than a year or two. For this one, since it tends to get pretty warm sometimes, we're going to use our regular solder to tin that new diode. Pop that on there. Lovely. Beautiful. And that's it. Switch our cameras all around. Let's cool this board off for just a few seconds here and then we'll give it a test. That's good. Alright, let's put this together and see what happens. Same exact thing as before our repairs when we tested here. We're going to hook everything up. Get it powered on and see what our test results are. We're going to set our multimeter back down to the 200 millivolt DC scale since I'm fairly confident we got this fixed. And here we go. We'll wait for that to boot up and then we can trigger Siri, which will turn the amplifier on and give us a true test to see if we've got our DC offset fixed. And what do we got? Boom. Beautiful. We're hanging out at around 1 to 2 millivolts of DC offset. That is a significant improvement over the previous 2 volts that we were seeing earlier there. So this should get rid of any death farts. This should prevent the bass speaker from frying itself again here. And that's it. That's great. Ideally, we want this reading to stay under 10 millivolts. That's what I consider a perfect score. Audio industry in general tends to try to keep things under 50 millivolts DC. And once you start passing 200-300 millivolts of DC, that's when things can actually start causing damage. So this is an excellent score, and we've got the root source, or the root of that why that bass speaker fried. We got that all fixed up. Let's get this put back together as a whole HomePod, and that should be it for this one. $14 screws for the amplifier. Reconnect that ribbon cable. Very good. Power supply. Nope, that's the wrong screw. We want to use their screws here. Start putting our plastic rings in place. I'm going to cut that little extra bit of glue there off so it doesn't interfere with our top basket sitting nice and flush. There we go. Get that ribbon cable gasket put back in. Beautiful. Alright, let's run over to our parts pile here and find ourselves a good subwoofer to replace theirs with. Let's see here. I've got a few on my shelf, but some of them I just need to finish bending back into shape. Here we go. That looks like a nice good one. Booyah. So this one feels nice and smooth. The voice coil in there looks nice and golden copper colored. And it smells like a healthy subwoofer. So let's get that plugged in. We've already got our subwoofer gasket here put in. So let's plug that in and then set that in. Fish that logic cable through. And then we will screw the subwoofer down. Oh, hey Ivan, welcome to the stream. Let's see, Ivan asked, could you sell me some parts for my dead HomePod? I'm from Mexico. Unfortunately, I do not sell parts. I do not sell parts anymore. I strictly do repairs. There's a bunch of reasons for that I've already explained a few times in my Discord and a few past live streams, but basically what I suggest is instead of spending the money on parts from me, I would suggest you instead go find a broken HomePod or two for parts. That way you not only have the one or two parts that you need to fix your HomePod, but also a few other spare parts in case you mess anything else up or you come across anything else in the future that you also want to fix. It's a much better use for your money, and I also simply just don't have the stock to be able to sell parts to people directly anymore. So I hate to say it, but I can't and don't sell parts anymore. I didn't sell them for very long, and when I did, they went by real fast, and I got this huge deficiency in, well, a whole bunch of parts that no one wants, and then a huge shortage of parts that everybody wants. So I hate it, but it is what it is. Let's get this screwed in. And then I was losing money selling parts from HomePods to people. There's no good way for me to go around it. It sucked. I'm gonna have to put like a frequently asked questions section up on my website explaining why I can't sell parts anymore. It hurts. It really does hurt me. I wish I could. Now, if you just need some screws, boy, do I have screws. I'll give you screws for free if you need them. But I'm unfortunately pretty much out of any of the other common parts that people usually ask for, like especially these top covers here, or ribbon cables and subwoofer speakers, logic boards, amplifiers. You know, the stuff that tends to break, that people tend to need. I ran out fast. HomePods came too early to get the love they deserve from Apple's self-service repair program. If they had shown up just a few years later, then just maybe we would have seen parts available from Apple. But I think this HomePod was, or HomePods in general, were made around a time when Apple was quite anti-repair. And they do seem to be taking a few steps in the right direction now. They're not fully there yet, but they are getting closer. I just wish there was some way that we could get our hands on more parts instead of taking apart old broken ones for them. I will say what I do have a few left of. I've got, let me grab some of it here. Ow. Ow. So I've got a bunch of these shells. I've got a couple of displays. I've got a couple of the cables for these displays. I've got a bunch of screws. Obviously a whole bunch of the tweeters as well. And that's really about all that I have left as far as parts that I can give to other, or sell, give, or whatever to other people. Everything else has been scooped up and sent off. And I've got to keep a couple on hand for, obviously, the repairs that people send in. I got something in my eyeballs. Oh, and I've got a couple of the microphone boards too, and I have a couple power supplies as well. So if you happen to need one of those parts that I do have left, then I might be able to hook you up. But the most common parts that people ask for, like the top plastic cover, the mesh, logic board, amplifier board, and subwoofer, those are hard to come by. And they're just getting harder and harder. I can still smell their cooked subwoofer from here. It's on the other side of the room. Ooh, smelly. Here we go, the final piece. the big head floating, or as the big floating head in the sky would say, show me what you got. All right, it's powering up. We'll wait for that to finish booting up, and then we'll check it for the usual. We want to make sure it's got bass, and that the volume buttons line up and light up nice and even. Oh, looks like it's all booted up. What do we got?
I'm having trouble connecting to the internet.
Oh yeah.
For more info, check the Home app.
Volume buttons are lit up nice and even. We've got a nice bassy voice in our Siri again. So we'll go ahead and give this a factory reset and make sure that the bass comes through nice and clear without any sort of rattling or gasket leaks after the stream. We don't want to get hit with any funny copyright strikes. All right, Korey, your HomePod has been restored and it has full bass again. What are you doing, Bailey? Go get him. Go get him. Who's out there? Are you just eating? You just getting a munchin'? Yeah? Yeah. I thought someone was breaking into my house for a sec. Okay. Let's get our text updated here. Move on to John's HomePod without bass. And then after theirs, we can move on to Martin's, also with no bass. Let's open the box. Ooh, return shipping label. That always makes my job a little easier. I'm gonna go ahead and stick that to the box here now so I don't forget it. Wonderfully packed too, wow. Let's see if we can reuse this material here. I know you guys can't see what I'm doing, but I can't point the camera over here because obviously we've got people's addresses on their boxes here. Oh, very nice. Come on out. Give me the good stuff. We got him. Oh, we got a new message from Ivan here. They said, yes, in fact, it is the microphone board. When uncovered, it was damaged. Okay. Hey, Ivan, so if you want to go ahead and shoot me an email, I will get you hooked up with a new microphone board and get you up and running again. All right. Let's crack this open. Get rid of that power cable. And same thing as before, let's double check our symptoms here. It's supposed to have no bass. Let's find out. Booting up now. Alright, finished booting up. Let's check our sound.
I'm having trouble connecting to the internet.
Yeah. That's got no bass. Let's crack it open and find out what's going on inside. Let's see, can we smell it? Nope, it smells fine right now. But if they've got a good seal, then you're not going to smell the subwoofer until you've got it out. So let's get that top cover taken off. Easy peasy. Get the display taken off. I think I'm starting to smell it. I could be mistaken. I could be smelling the first HomePod subwoofer still. Come on. There we go. Oh, that's stuck in there. Booyah. Where'd the rest of our sticky go? Huh. That's okay. Let's get this frame taken out so we can take the logic board out. Detach that ribbon cable from the basket. Very nice. Expose those screws for the basket. Get those screws taken out now. Try to keep my screws organized. Time for the pry. This one's coming up nice. What do you guys think? Are we gonna have 3 for 3 bad subwoofer speakers here, or are we gonna get a little lucky? Interesting. We don't need that. Get out of here. Now, time for the subwoofer. Be free, little doofoofer. All right, what have we got? Feels nice and smooth. Voice coil looks good. And it smells good. So we might have ourselves a good subwoofer still here. Very nice. It does beg the question though, what is wrong? What do we got? Of course we will get this amplifier taken out and then hook it up to our known good subwoofer here just to make sure that that original subwoofer there isn't the actual source of our problems. But I see no signs on that subwoofer of DC offset causing any damage, so I have high hopes. Get that power supply disconnected and removed. Time for the amplifier to come out. Just 14 more screws. here we go. Alright, let's do a visual inspection of this board really quick, see if we find anything obvious. This side looks good. And this side looks good. So let's power this up, get it connected to a good subwoofer, and see if perhaps the subwoofer speaker is actually bad despite our sniff test. And here we go. There we go. Alright, that booted up pretty quick. And well, we've got absolutely zero DC offset, but that's probably because the audio circuit's malfunctioning, which is obviously causing our no bass issues here. So most likely their subwoofer is still in good condition, but that means that our no bass fault is indeed coming from the amplifier this time here. So let's take a closer look at that and see if we can figure it out. Most likely we've probably got a short on the back of this board near the amplifier. If not, then perhaps the amplifier chip itself there might have blown up, but it looks like it's in good condition still, so I doubt it. Let's get you guys up close. Okay. So we're going to grab our multimeter, stick that into continuity test mode, so it beeps if there's continuity, or in some cases that'll tell us if it's shorted. And I'm just going to jump right into what I think is probably shorted out based on personal experience. Just making sure we've got ground-to-ground continuity there, that's good. And then this little capacitor, I believe this is a capacitor right here, tends to short out. And lo and behold, first guess, that's our short right there. And we can double check. Yes, indeed. Well, that was an easy diagnosis. Let's grab a parts board. Since I haven't quite figured out exactly what that component is or its values, I have to harvest it from another amplifier, which I've got a few sitting around just for parts for these occasions. Here we go. It looks ugly, but it's chock full of good parts still. So let's test that on here and check and make sure that it's still good. Yes, sirree. We've got a good capacitor on that parts board there. So let's get it pulled off our parts board. And then we will put it onto our good board here. Come on off. There we go. And then let's turn our attention over to our board for repair here. Get that bad one pulled off. There we go. Alright, now I'm curious, first of all, if that was the source of our short. Yes, it was. And here's our good one that we pulled off our parts board. That's still good. Now I'm curious also if we can measure its capacitance here on our good one, so we can hopefully find replacements. I'm honestly not even sure if this is a capacitor. Oh. It's got a pretty high capacitance if it is. Alright, so we're measuring around 29 microfarads on this capacitor here. 28, 29 microfarad. I have no idea what the voltage rating or tolerance of this guy is, but maybe we can nail that down with some more research. Let me write that down so we don't forget it. No base short on 29 microfarad cap. And then let's grab our calipers, take some physical dimensions. Looks to be about 2 millimeters in length and probably 1 millimeter in thickness, if not like 1.5 millimeters. So we're about 1.3 millimeters thick, 2 millimeters long. So 2 millimeters by about 1.3 millimeters. We're gonna have to look up the SMD size chart and see what that closest size is there, because I'm sure my cheap Harbor Freight calipers here aren't spot on, but they tend to get the job done. Alright, let's put this bad capacitor in our dead parts pile and put this good capacitor onto our board and see if we've got our base back. Dang, my camera does not want to focus on that. There we go. Hey Tim, welcome to the stream. You got a shout out on the Accidental Tech podcast that came out last Thursday. I know. I've been inundated with emails and YouTube comments ever since that episode came out. It's a good thing, but it's made me consider hiring my own social media manager. Oh, bullocks. Knocked that resistor out. There we go. Let's get some flux back on there and try to put that capacitor back on, if we can find it. There we go. A little more flux and heat just to make sure that's on there nice and solid. There we go. Tim said charge more. I couldn't do that, man. I've had a lot of people tell me I could charge more for repairs, but I can't do it. The whole reason why I priced the repairs the way and where they are now is, well, people already paid enough for these speakers as it is, and especially for the international repairs. I try to keep my prices down to the point where, for the cost of repairs and shipping both ways all in, it ends up being cheaper than paying Apple for the out-of-warranty replacement. That's my goal. And I am fortunate enough right now that this is not my primary source of income. I do have a normal, day job that I've got that pays the bills. Is that on there nice? Seems so. Somebody's alarm is going off. Hey, knock it off. What is your day job, if you don't mind me asking? So I can't give too much detail, but I can say this. I've worked at a software company for the past just about 10 years now. Primarily, I support the sales team with a whole bunch of things, from demoing and installing our software for potential customers, to training on our software, troubleshooting, and integrating new hardware as well. So I get a wide range of challenges and things to work on during the day, and then I get to crack open a few HomePods at night. Okay. So we've replaced that shorted capacitor on the bottom of that amplifier. Let's put our parts board away. And let's power this up and see if we've got our bass back. If we do, then we will replace our Schottky barrier diode, as is the usual for all of the HomePod repairs, just as sort of preventative maintenance. Those Schottky barrier diodes love to short out and cause no power issues. It's the most common thing these things come in for, and the part's only $1 a piece, so we may as well get it replaced for every HomePod while we've got it apart. Hopefully prevent that no power issue from popping up on them, anytime soon after repairing any other issue that we've got here. But first, do we got bass? Sales engineer. Pretty much. I am pretty much a sales engineer, but I'm not strictly restricted to sales engineer roles per se. I get pretty heavily involved in the QA process, I help our support team here and there with Tier 3, Tier 4 escalation issues. I've got a pretty in-depth knowledge of how our software works and how to troubleshoot it, so quite often people come to me whenever they've got issues with it. I wear many hats, and I've worn many hats at this company over the past 10 years. I actually started as a accounting assistant, and then moved over to Tier 1 phone support, went over into QA, became QA lead for a while, quit that and went to work in the production group in the warehouse. Only did that for a few weeks before I went back to QA, and then I went over into where I am now, pretty much sales engineer, with a taste of a few other things here and there. Alright, so let's see if this board boots up, if it gives us any bass. I'm curious if it's got any DC offset issues as well. If so, we'll go ahead and replace those filtering capacitors, and then we will replace that Schottky barrier diode too, like I said, to prevent the no power issue, and then we'll be in good shape. Oh. Do we got bass? Let me try to turn the volume up here so you guys can hear her, but I hear bass. Give me the volume buttons. Alright, where's my iPad? I'm not playing games. I named this logic board Tortured Soul, so we'll connect to that. Crank the volume up. And we got bass. Beautiful. And only 2 millivolts of DC offset to boot. That's beautiful. So this doesn't have any DC offset issues to worry about. We won't bother replacing the filtering capacitors. But let's go ahead and replace that Schottky barrier diode, and we will put this HomePod all back together again. Hey Hans, welcome to the stream. And yes, that's all great news. Everything is within spec. We've got our bass back. We've got no significant DC offset. We're just going to replace this diode on the other side here to prevent the no power issue from occurring anytime in the near future. And then this HomePod will be ready to rock again. But that is excellent news. Couldn't ask for better results here. Where's our tweezers? There they are. Oh, well, I appreciate you trusting me with your HomePod. It's always a pleasure getting these fixed and figuring out what's wrong with them and bringing them back to life again. Especially on the cheap. Compared to Apple's $300 ask for an out-of-warranty replacement that's just going to have the same problems a few months down the road. What date code do we have on there? 1748K? Yeah, it's a good thing we're replacing that now. Let's get a new diode. Excuse me. You talking shit?
You done?
No.
Yeah, I'm talking shit. I mean, shit talk.
Clean up that extra little solder there. There we go. Looking good. That's it for this board. Let's throw this HomePod back together and give it one quick final test, all fully assembled, and we should be good to go. Ooh, hot, hot, hot. Very hot.
Not to be rude, but, you know, having my house in there.
Everyone's talking shit.
Okay. Yeah. We're gonna, I'm gonna put this in that other room right now.
Oh no. Up against the wall right now. No, because the door can't come off control. So, I'm gonna leave this stuff here.
Alright, then get that logic cable reconnected. Get our power supply. What's up? Everyone's talking shit. for our rings. Don't break my HomePods. Get this gasket in. Get our subwoofer in.
And another good thing is get you, I don't know if you can find any, line, that you might be able to find the fake ones and put them and hang that in
Screw
your
that
shower.
down.
And then when the steam hits it, it will open up.
no. Get back in there. How many more do we have tonight? We've got, we just have to button this one up, and then we've got just one more. And it's an easy one for us, actually. It's just the amplifier board itself, which also has no bass. And we're going to fix that amplifier up for them, and then they also need a new bass speaker. So when we send that amplifier back to them, we're going to send them a bass speaker with it. Just one more, though. I see my text is a little off screen there. There we go. All right. I see a bit of a stain here. We should be able to clean that up with some rubbing alcohol, I think. I won't bore you guys with that here on stream. I'll do that after. So here's our power. Let's plug it in. Nice. We'll wait for it to boot up, and then we'll of course check and make sure that it's got bass in this series sound and volume buttons light up nice and even. All right.
I'm having trouble connecting to the internet. Or info. Check the Home app.
Beautiful, beautiful, beautiful bassy Siri, or should I say Seth. And
I'm having trouble.
our volume buttons light up nice and even.
I'm having trouble connect.
All right, that one is ready to rock again. 2 for 2, guys. On a roll. And last but not least, we've got Martin's amplifier board here with no bass. So let's get our text updated there. There's got to be a way for me to have this text auto center to the corner of the screen there. I'll figure it out. And here we go. So we've got a printout here just with our email correspondence and their return address. That makes it a little easier for me. And here is our amplifier. Ooh, it smells. It smells burnt. Oh, wow. Yeah. Probably from the bass speaker that cooked itself. Alright, so let me read our email here really quick again. So, original symptom, bass stopped working all of a sudden, HomePod operates normally otherwise. Let's see. Using the directions on your site, I disassembled it. Once opened, I can smell the distinct odor of burnt electronics. Upon closer inspection, it is clear that the woofer is toast, both literally and figuratively. So I'm assuming the DC offset issue. The coil is black, even though the woofer moves without distortion or making any noise. Alright. So yes, if the woofer looks burned and it doesn't pass the sniff test, then it is... even if it works fine, if you were to test it, I would suggest replacing that speaker because it's not much longer for this world. In any case, their original guess is probably spot on here. They've probably got too much DC offset, again, coming from these capacitors giving up doing their duty, and that's probably what killed their subwoofer. So let's power this up, connect it to our good woofer with our multimeter, confirm that we do indeed have enough DC offset here to be causing damage, and then we'll replace those filtering capacitors. While we're at it, as usual, we'll replace that Schottky barrier diode to prevent any no power issues. Then we'll retest the board, make sure it's all good, and then we'll ship it back to them with a good subwoofer and they'll be good to go again. Alright, let's grab a power supply. Put some screws in that so it doesn't pop out on our bench here. That would be really bad if it did that while we were powering it on. That's why I put screws in this whenever we test it. And then our logic cable. Lock that cable into place. Get our logic board power cable, subwoofer, multimeter on, and here we go. Keep an eye on this subwoofer here. After this boots up and I wake up Siri, keep an eye on that woofer. See how much it moves. I'm gonna hazard a guess, if it cooked their woofer, we're probably gonna see around 700 millivolts of DC offset, but it'll also quickly grow to probably 1.5 volts here. Let's find out. Oh, right on the money, 600, and we're almost at 700 now. There we go. I'm sure if we hung out for a little bit here, we would see this continue to grow past that point of safety, and it would cause a death fart. But that's, I've seen enough here. Oof, and heard enough. Let's get that fixed. Wee. And there we are. Let's get those capacitors pulled off and replaced with some good ones. There we go. Grab some fresh new ones. And then we're gonna tin those pads with some low temp solder. Make it a little easier to put those new ones on. Subject them to a little less torture. There we go. A little more flux and we'll put those new caps on. Beautiful. A little more flux and heat. Get those on there nice and solid. Very nice. Alright. Let's get that Schottky barrier diode replaced for our no power issues. Keep that from happening on here. It's got a date code of 1726K. So it's an old one. No, all my flux. Beautiful. Not quite. It's a little crooked, and I'm a perfectionist. There we go. And that's that. Let's cool this board off for just a second, and then we will retest it. That should do. Make sure those are nice and cool to the touch, and then we can give this a quick test. power this up. Let's see what we got. Yeah. We've got a solid 0 to 1 millivolts of DC offset here. Couldn't really ask for a better result there. And give me the bass. Show me a sign. Oh, it's gonna play music. Well, that works. Awesome. We got all 3 HomePods with bass issues fixed up today without a problem. If y'all have any questions about any of the repairs that I did here or in general, feel free to drop down a comment below, or you can visit my website, nixfix.com, where I've got all the common issues, how to diagnose, repair those issues, and the parts that I use to repair those issues. I've also got my contact info up on my website there, so feel free to shoot me an email if that's your preferred method. And I'll catch you all in the next live stream repair. Goodbye!